All right, welcome geometry students. This is Mr. Matt over at Williams High School, going over the topic 6 and 7 test review. This test is all about triangles. The angles, exterior, interior, triangle congruence, proofs. It is quite a topic. Hopefully you have your review packet or your test review paper. Before you watch this video, I want you to pause it if you have not tried any of the problems. Try the problems first. If there are problems you cannot do, right, circle them, put a red star next to them, right, mark them so you can go back and check, right, with this review. So hopefully you're only watching this review after you've tried everything. That way, you've given yourself effort, you've given yourself time and effort to learn this stuff. Right? If you just listen to me do it all for you, you're not going to learn, right? I want you to practice so you can master this for the test coming up on Thursday, November the 7th. That is right around the corner. So yes, pause the video, go try the answers, circle the ones you can't do, and then come back to the video, focus on the ones that you didn't, that you couldn't do, all right? So I'm assuming everybody that's back, y'all are the ones that have tried the answers, you've tried the questions, you've gotten some answers, and we're going to go check them here. Again, fast forward through the video to get to the answers that you want to skip to. Hopefully you find out where you went wrong and you learn. All right, the materials, please make sure you have a pencil, some sort of calculator, right? I don't care if it's your iPhone or if you have like a calculator at home, you can use the Desmos one, but we are going to be like adding and subtracting from 180 and doing some stuff like that. Also, if you have your triangle foldable, the one that we gave out in class, bring that too, all right? Pull that out of your backpack. It will help you with some of these problems. So without further delay, let's go ahead and get started with our review. I'm doing this on my iPad, so I will have a bunch of different colors and all sorts of things. You'll see me write something and then erase something and then talk loud and, all sorts of stuff. So if I'm going too fast, pause the video, all right? Rewind, okay? Send me an email and say, Mr. Matt, you talk too fast, right? Something like that, okay? I am also a student and I'm learning, okay? So let's get started with triangle congruence, okay? So first couple questions here, we want to determine if you can conclude that triangle RXY is congruent to triangle SXY based on the given information. That's what we want, right? And if you can conclude they are congruent, then state the postulate or theorem that allows you to make this conclusion. As a review, and hopefully you have this on your foldable, the 5 that work, the theorems that work, are side, 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 SSS, side, angle, side, the angle between two sides, just like the A is between both S's. Angle, side between two angles, right? Angle, angle, side, that's enough. Or the hypotenuse and leg of a right triangle, right? If both triangles are right triangles, that works. So we need at least 3 things here. You see 1, 2, 3, 1, 2, 3. All of these are 3, 3, 3, 3. We need at least 3 things to prove that 2 triangles are congruent. And it has to be one of these 5. So let's consider A. It says RX is congruent to SX. So I have a picture here and I can label these sides. If it tells me, might as well. It might help you to visualize that, right? So RX is this side. You can mark that side congruent. And it says it's congruent to SX. So on the other triangle from S to X, congruent. What else do we have? Okay, we have RY is congruent to SY. Okay, well, RY is here. I'll mark that. SY is here. I'll mark that. So I have 2 things the same. Remember, you need at least 3 things the same. One of these. We don't have 3 things, but my recommendation is look at the picture and try to see if there's anything both triangles have. They both have this middle line, YX. On your delta math, it marks them like that, puts a little X on it. I like to draw like 1, 2, 3. But they both have that third side, which means that the triangles have S, S, S congruence. So this is a yes by SSS. We can put a check mark next to that one. Wonderful. All right, let's go over to B now. Again, we're going to use the same strategy, right? I'm going to mark what I have. I'm given these things. I'm going to mark them in my picture, and then I'm going to try to see if there's anything else common, right? So RY is congruent to SY. All right, that's this part here. In fact, I'll make it red just like the last one. RY, SY. Okay, that's the same. What else does it give us? Oh, it gives us an angle. Angle R congruent to angle S. That must be the angle here at R and the angle here at S. And then what else? Well, just like the last triangle, it has that common side, XY. So this side. Nice. So I have one angle and two sides. So I have side, I have another side, and then I finally have my angle, SSA. Is this enough? It's not one of our 5. Look on the right. It's not one of them. No. And if you spell it backwards, it's the bad word. Bad word. Does not work. So no, not enough information, right? I don't have enough to prove that these two triangles are congruent. Okay, let's move on. Number C, it says that XY bisects angle RXS. So XY is this line here. And let's mark our angle RXS. So from R to X to S, that must be this angle here. So this red line cuts that angle in half. So my two blue angles must be congruent, right? So I have an angle here that's the same, right? Angle on this side, angle on that side. And then I have the common side. That's all I have. So I have a side and an angle. Is there anything else that's the same? No. That's all I have. I just have two things. And is two things enough? Again, if you look over here on the right, we need at least 3 things. 3 sides, 2 sides and an angle, 2 angles and a side, 2 angles on a side this way, or the hypotenuse and leg of a right triangle. This is only 2 things. It is not enough. We can't do it. All right, D. XY bisects angle RXS and angle RYS. So I have a couple of things happening here. This line bisects this angle here and this angle here. So let's mark our bisector. Our bisector is XY, right? And our two angles are XS. That goes from R to X to S. That's this angle here. And then our other angle, RYS, which is this one. So again, this red line will cut both of those angles in half, right? So my two smaller blue angles, this angle here and this angle there, must be the same. The same for my green angles, right? So that means I have both triangles share a blue angle. Both triangles share the red side in the middle, just like with the other triangles, and both triangles share the green angle, all right? ASA. The side is between both angles, just like in our picture, and we will find that is one of our postulates. ASA is right here. Wonderful. All right, 2 more. XY bisects angle RXS. Okay, and then what else it gives us? It says, hey, also these sides are congruent. RX is congruent to SX. All right, so let's label our angle, RXS. That's right here. Let's label our bisector right there. It cuts that angle in half. And then let's label the other side it gives us. RX, which is this side here, is congruent to SX, which is this side here. Wonderful. Okay, and remember, that common side is shared. So it looks like both triangles have a green side, a blue angle, and a red side. So that is side in the middle, the angle, and then another side, SAS. And we will find that is, again, one of our 5 postulates. It is right there, SAS. Wonderful. Okay, now on to F. This one's a little bit tricky because it has this symbol here in the middle. Remember, once you see that symbol, this stands for perpendicular. Perpendicular. And it basically tells you that these 2 line segments, RY and XR, must meet at a right angle, right? This little perpendicular symbol is kind of telling you that, hey, there's a right angle here. That's the story it tells, right? Okay, so let's mark things on our picture that we know are going to be the same, right? So RY is going to be perpendicular to XR. Okay, so RY is down here, XR is here, so it means they meet at a right angle. Also, it tells us SY is perpendicular to SX or XS. So SY is here, XS is there. That means they meet at a right angle. What else does it give us? It says, hey, also RX is congruent to SX. So RX is this side, SX is that side. Just like before, and you can hear the bell there from the school. Shocker where I'm at right now. So go ahead and find the common side, right? Just like before, they both share this middle side. So I have 2 sides and an angle, right? So you might be tempted to write SSA and say, oh, that's not it, right? That doesn't work. But look, it is a right triangle. And we have the hypotenuse, which is the red side, and we have a leg, which is the blue side. And of course, both triangles are right triangles. This is enough. So yes, 2 of these don't work. That's B and C, and the rest of them do. All right, moving on. Ooh, now we have an algebra question, but geometry is involved, right? So let's read it. It says triangle AMC. Hey, I like that movie theater. Is congruent to triangle QRP, where AM equals 29, MC is 30, AC is 31, and QP equals 2x plus 1. Solve for x. What else does it want us to do? Draw a diagram to support your answer. Yes, please draw a diagram, right? So let's go ahead and start with our diagram. It doesn't really, when you're doing a test, right, if you're drawing a diagram, it doesn't really matter how you draw the triangle, right, as long as you label it correctly. So I'm going to draw this triangle kind of indiscriminately. Here we go. This can be my first one, so AMC. And I'll draw my other triangle. In fact, this one's actually a little bit too big, so forgive me. I'm going to make it a little smaller. So I will zoom in a little. Here's AMC. AMC. We'll put it right here. And then our other triangle is going to be QRP. And they're congruent, so I can draw them, you know, kind of about the same. So Q lines up with A, R lines up with M, and P lines up with C. So here's my 2 triangles. And if they are congruent, that means corresponding sides and angles must be the same. So AM's got to be the same as QR, right? MC has to be the same as RP. And lastly, AC has got to be the same as QP, right? Now let's try to solve for x, all right? We have our sides of our triangle labeled. We can also label the angles, but we're just going to worry about the sides because look, it just has all the sides here, right? AM, MC, AC, and QP. And let's look at the sides that are corresponding. We want to solve for x, right? So we'll take QP here because it has the value for x, 2x plus 1. And that is our green side on this side of the triangle, right? QP. And we want to find a segment that it's congruent to. So we look at the other triangle, that's going to be AC. So QP and AC are the same. You can also get this from the statement. Q and P are the first letter and the third letter of this triangle, just like A and C are the first letter and the third letter. So they must line up. So because of this, I could then say, hey, the value for QP, right, is 2x plus 1. And the value for AC is 31. If you don't trust me, it's right here. Which means these 2 guys have to be equal. When your teacher is looking on your work page to give you points for extra credit or if you missed a problem, that's what they want to see. They want to see, did you write that equation out? Right? If you made an algebra mistake, that's one thing. But did you get the equation? Because that's the geometry. Without this, you're kind of doomed. Okay, now we're going to solve this. Since 2x plus 1 has to be the same as 31, they have to be equal. So I'm going to write that here on the side. 2x plus 1 equals 31. And I'm going to use my algebra method, right? So I'm going to subtract 1 on both sides because I want to get 2x alone. I will simplify this. What do I have left? Okay, I have 2x and 30. I need to get rid of that x, so I will then, the 2 I will divide so I can get rid of this. Of course, you have to be fair to both sides, so you divide both sides, and then your final will be x equals whatever 30 divided by 2 is, and I hope your calculator gets 15. If it doesn't, something's wrong with it, or you put something in wrong. Okie dokie, solve for x, and we have our diagram showing that they're the same. You can label your diagram more if you want, but that's just kind of the basic. Okay, number 3. If triangle JDP is congruent to triangle TYK, which of the following is not true? Okay, please be careful. Not true. Not. So that means one of these is false, the other is true. Okay. So let's look at these statements and let's figure out which ones are which, right? So before we do this, right, I'm going to just quickly remind you, if you have your statement of congruence, triangle JDP congruent to triangle TYK, just like we kind of alluded to on problem 2, right, the letters correspond to each other, right? So the first letter goes with the first letter, right? The second letter goes with the second letter, and then the last letter goes with the last letter. right? So that means that J is going to correspond to T, right? D is going to correspond to Y. And lastly, P is going to correspond to K, right? And if it's lined up like that, you know it's good. So with that in mind, let's go ahead and consider answer choice A. Is this true? It says PJ is congruent to KT. And if we look over here, P goes with K, and J goes with T. So this looks good, right? P with K, and then J with T. So the lining up is good. So this one is true. That's not the answer we're looking for because we want to find the one that is not true, a faker. All right, number B, angle D congruent to angle T. Well, look right here. D needs to go with Y. Aha, we have found the faker. B is not true. This has got to be the one that we are looking for, right? And we can consider the other ones real quick, right? P goes with K as the third one. Yes, it does. That's correct. And lastly, DP goes with YK. Yes, so D will go with Y, and P will go with K. Yes, that looks accurate. So answer choice B. Moving on, number 4. Ooh, okay, so these are a little bit more intricate. So what do we need to do? It says label the drawing according to the given information and state the postulate or theorem that can be used to prove that the triangles are congruent, right? And again, remember those postulates and theorem, SSS, SAS, ASA, I know I'm writing this again, right? AAS, and then the hypotenuse and leg of a right triangle, right? So those are our 5 that work. Let's go ahead and zoom in on number 4, and let's figure this out, okay? So given B is the midpoint of AD, and I guess true here, maybe it's just me, right? B is the midpoint of CE. So here's the 2 things that are given, right? Okay, let's figure this out. So if B is the midpoint, I'm going to mark it here, right? Maybe I'll mark it in red. If B is the midpoint of this blue line, AD, right? That means that this piece, AB, has to be congruent to this piece, BD. That's from the definition of midpoint. But also, it says that B is the midpoint of CE, right? From C all the way to E, right? So I'll change this point to green, right? So that green point's in the middle of the red line, which means that CB, this part, from C to B, has to be congruent to the other part from E to B. So both triangles have a blue side and a red side. What else do they have in common? Remember, vertical angles, they don't go away. Whenever you have 2 lines crisscross like that, right? They could be lines or segments. The angles on the left and the right are vertical. That means they're congruent. Also, the angles on the top and the bottom are congruent. So if I look into this picture, I have my red line and blue line crossing. That means this angle here, right? That's angle EBD is congruent to this angle there. That's CBA. So that is enough because now both triangles have a side, the angle between, and a side, right? A side, the angle, and a side. So that is SAS. And I'll write that on the side. Side, angle, side. They both have a blue side. They both have the purple angle. Excuse me, that's not purple. And they both have a red side. So ABC, be careful when you're writing this congruent statement. You have to line up the letters correctly. So A is going to correspond to D, right? They're both on that blue line, so D is going to be next. B is going to correspond to itself at B, and then C is going to correspond to E by SAS. It's a little tricky, but we've seen this bow tie problem in class. Yeah, it's not going to go away. I would really practice on that one. It's one of our favorites. As your teachers, it's one of your teacher's favorites. It might not be your favorite. That's okay. All right, let me just check here. Yes. All right, so in triangle ABD, triangle DEF, let me read this. Triangle ABC, sorry, triangle DEF. If angle A is congruent to angle E, and angle F is congruent to angle B, and AC is congruent to DE, then which statement and reason is true? I forgot where that true part is, right? So let's label, when you're given information, label the things on the triangle that you know are true. So we'll do the first part. Angle A is congruent to angle E. So angle A congruent to angle E. Notice it's not congruent to F, it's congruent to E. The other triangle is just flipped around. What else? Angle F is congruent to angle B. Okay, I can mark B and I can mark F. What else does it have? AC is congruent to DE. So that's the side AC is congruent to the side DE. Are these triangles congruent? Look for one of these that might work. And notice I have an angle, right? Angle B, I have another angle here, and I have a side. Two angles and a side. Just like the other triangle, angle, angle, and side. This is starting to look like angle, angle, side congruence. Because that green side is not between the angles, just like the S is not between the A's. It's on the side. So we have enough. Angle, angle, side is one of our 5. Voila. So let's write our statement. Again, be careful when you are ordering the letters, right? I got A, B, C over here. It needs to be in the order that the picture dictates, right? So A right here is going to correspond to, it's got to be E, right? Because those angles are congruent. So E is going to go here. Put that in red. B, okay, that's the red angle, corresponds to F. That's the other red angle. And then what's left, right? C has to correspond to D. It's always easy to get the last one because there is one point left, one angle that we haven't talked about. Okie dokie. Number 6. This one's a little bit different of a question because it says what additional information is needed to prove that triangle MNP is congruent to triangle UVW by the angle side angle congruence postulate. So we want angle side angle, that's ASA. So we want two angles and the side between, right? S is between, the side between. So let's look at our picture and let's just kind of like notice what we have already, right? So notice I have this angle here marked with that angle there. So I have one angle already. And I have angle N marked with angle V. I have two angles, right? So I just need the side between both angles, right? And the side between the blue angles over here is from N to M. You just connect the dots. This is that side. We need this side congruent to the corresponding side over here, which is going to be from U to V. If we have that part, then we do truly have ASA. So what additional piece of information do we need? That piece of information is going to be this. We need MN to be congruent to UV. When we have that, we have enough information to prove the triangles are congruent by angle side angle congruence. Number 7 is a similar problem, but instead of trying to find enough for angle side angle, we need to have enough for hypotenuse leg, right? So I'll read this one again. What additional information is needed to prove that triangle QRS is congruent to triangle XYZ by the hypotenuse leg congruence theorem? Okay. First things first, label what we have. So we have this side RS. You do a better job there. RS is marked twice. It's congruent to YZ. And we have RQ marked here, congruent to YX. So we have two sides. We don't have enough for hypotenuse leg because, again, remember hypotenuse leg is the hypotenuse and leg of a right triangle. So we need the triangles to be right triangles, which means we need right angles. So if angle Q was a right angle and angle X was a right angle, if these two are right angles, then we would have it, right? So what would be enough information? Right, that would be angle Q and angle X are both right angles. That would be the missing piece of information we would need to prove the triangles are congruent by hypotenuse leg. Okay, moving on. Okay, if angle A, so we're using this picture down here, right? If angle A is congruent to angle D, and angle C is congruent to angle F, then which additional statement does not, be careful, does not prove the triangles are congruent, ABC and DEF? Okay, let's mark what we have in the picture, right? So A is congruent to D, these two angles. Okay, so A and D, okay, that's true. What else does it give us? C, and F, so angle C and angle F. And this is tricky because it says which additional statement does not prove they're congruent. So let's consider each statement until we get the one that doesn't help us prove they're congruent. So consider the first one, right? Let me change colors here. Let's do, yeah, no, it's fine. I'll keep it as blue. Consider if AC was congruent to DF, right? So if AC here was congruent to DF here, if that was enough, then we would have two angles and the side between, ASA. But that's enough to prove they're congruent. So A is not the right answer. Nope. Again, we're looking for the one that does not help us prove it. That helps us prove it. So forget about that one. What about AB congruent to DE? Okay, well, AB is here. DE is there. If I do this, I have two angles and the side, the corresponding side that's not between. So I have angle, angle, side. That helps us prove it again. So nope, can't be that one. Cross that one out. Third one, angle B congruent to angle E. Okay, so if we marked angle B, 1, 2, 3, and angle E, 1, 2, 3, would that prove the triangles are congruent? Now we have angle, angle, angle. No, angle, angle, angle doesn't work. Remember, AAA, that is our bad battery. AAA battery, you can see them in remote controls, right? Bad battery does not work, just like bad word does not work. So these triangles, although they have the same angles, that's great. They're similar, but they're not the same, all right? That we can't prove they're the same because one could be smaller, one could be bigger, right? They can be different sizes and they can both have the same angles, right? So our answer is clear. It's got to be C. Again, that's because A doesn't work. Not enough information. Number 9, which statement is true? Okay, so let's read this. Triangle CXE congruent to triangle JGK. Which of the statements is true? So we're looking for one of them. Again, you know, when you have the statement here, go ahead and write out the corresponding letters. C, X, and E. We'll take the first triangle, right? And corresponding. So C corresponds to J, right? So J. X must correspond to G because it's the second letter. And then E corresponds to K. So we're going to look at these and see if any of them have the same correspondence. All right? So let's try it, right? We'll try number A. So A says X goes with J. Wait a second. X goes with G. Wrong. It can't be A. Get rid of that one, right? So A is out of the question. Let's try B. B says E goes with G. Well, E goes with K. It's not B, right? So it's not A and it's not B. What are you left with? In this case, we have C, but let's double check it, right? C says that C goes with K. No, C goes with J. Maybe I'm missing a statement. Oh, I have D down here. Okay. Yes, indeed. So this one's also wrong. C goes with K. That is not correct because C goes with J, right? So it's not A, it's not B, it's not C. There's actually a hidden answer choice, D. Let's consider this one, right? It says X goes with G. Yes, it does. It says C goes with J. Yes, it does, which means the last two, E and K, are the last letters. Correct. So my answer is, answer choice D. That is the true statement. All right. Complete the following flow chart proof. Make sure everything's lined up here. Remember, when you're doing proofs, use the given information first if you can. Nicely, though, it's nice that there is the flowchart's already kind of written for you. You just have to fill in the blanks. So you don't have to do the entire proof, basically, on your own, like you did in some of the Delta Math, right? So this is much nicer. All right, let's dive into this. What are we given? It says that BD bisects angle ABC, okay? And angle A is congruent to angle C. So I'm going to mark the angle first, ABC. Okay, ABC, so that's this angle here. And I'm just going to play with the picture before I do the proof because that can help me. And then BD is the bisector, so BD cuts that blue angle in half, chop, just like I did there. And then lastly, angle A is congruent to angle C, so I'll mark angle A, and I will mark angle C. Voila. And what are we trying to prove? That the triangles are congruent. Okay, let's do this. So let's start here with our first statement. BD bisects angle ABC. And notice that that is right here. So it is part of our given information. We don't have to work very hard for that. Our reasons go there. And again, for a flowchart proof, remember in the box, that's going to be your statement, right? Your statements will go in a box. And then underneath it will be your reason. So this is how a flowchart proof works, right? So statements go here, reasons go underneath it. So I need a statement here, a statement there. I need a reason here, I need a reason there. Those are the places we want to fill out our information, right? So let me erase all this stuff, and then we'll look at the next statement. Okay, so I have an arrow going from here to here. That means I need to use this piece of information to prove something. So BD bisects angle ABC. What does that mean about these blue angles? If BD, the red line, is the bisector, it cuts those angles into two equal halves. So the little blue angle over here, ABD, has got to be congruent to the little blue angle over here, CBD. So I can write that down. ABD, this angle, that's got to be congruent to the other one, CBD. And that is from the definition of the angle bisector. There's our reason. Awesome. So I have two angles congruent. What else? Let's go to our next one. Again, we can't take this arrow down here yet. We can't prove this one yet because we don't have these two first. So let's go ahead and get these two boxes, this one first, this one second, before we can get to our final box and prove the triangles are congruent. This one has a missing statement, but it has the given as the reason. So what thing in the given have we not used yet, right? We've used the bisector part, check mark, but we have not used this part yet, so we might as well use that. Let's go for it. So angle A is congruent to angle C, and that is given to me. Nice. So far I have gotten an angle that's congruent and another angle that's congruent. It would be nice if I can get a side that is congruent. Aha, and the last statement here, before we go to the final one, it says BD is congruent to BD. And notice that BD is the red segment in the middle that we have marked. That is our angle bisector. But it's also on both triangles. Both triangles share this BD line segment. So we can claim they are congruent by the reflexive property. Here we go. And again, the reflexive property just says that, hey, x equals x, right? Any number equals itself, and that's the same with congruence, right? Okay, we have enough now. So we have two angles, and we finally have a side, right? So the only question is it going to be ASA or will it be AAS, right? Which one of these do you think it is? And, go ahead and pause it and try to figure it out, right? Remember, if it is AAS, the side has to be between both angles. But if it is ASA, the side, I misspoke, right? If it is ASA, that side is between both angles, just like the S here is between both A's, right? If it is AAS, that side is not between both angles, as the S is over here on the side, right? So if we look at our picture, the side is here, it is not between both angles, right? If the side was here, that would be between the blue and the green angle, right? That would be between the angles, right? But I don't have that. So it's got to be angle, side. Voila. Okay. And that is enough to prove our triangles are congruent. Okay, now it says rewrite the flowchart proof from problem 10 as a 2-column proof. Use as many boxes as needed. We should only need these amount of boxes because there's 5 boxes over here, which means there'll be 5 here. This is honestly not as bad because you already have the entire proof done. You can just, as I said earlier, right? You got the statements and underneath you got the reasons, right? So if I circle my statement and box my reason here, I'll put my statement here and the corresponding reason will go there, right? So I'll just fill them in and get each and every statement and reason. Luckily for us, we have all the statements, so this is now just a matter of copying them into the right place, okay? So let's put them in order here. You can kind of, pick the order that, would make most logical sense. I'm going to scoot that over. So I'm going to say this one's my first statement here, first statement of reason. I'm going to follow the arrow and say this is my second statement of reason. I can't follow the arrow again and do this one. That has to be the last one. So this has got to be the fifth and final one, right? Which means this one and this one will be the third and fourth one, right? So with that in mind, let's go ahead and put them in their respective places. So statement 1, BD bisects angle ABC, and that is given. So that's our first. Second one, from that, we can say, hey, angle ABD must be congruent to angle CBD. Those were our two smaller blue angles. That's from the definition of the angle. I'm going to use the angle symbol, bisector. Third statement, angle A congruent to angle C. That was also given. Nice. Fourth statement, BD, that side was congruent to the corresponding side BD, and that's from the reflexive property. I'm going to say reflexive prop, put a period there. So I'm abbreviating it. Then our fifth and final statement, hey, these two triangles are congruent, so ABD, that's got to be congruent to triangle CBD by the angle-side postulate. There we go. So again, this one's quizzing you on the flow chart, filling it in, and then of course, can you take a flow chart and then can you put it as a 2-column proof? Just be careful. I would highly advise doing the number system of numbering them in order. That way you know where to put them when you're doing your statements and reasons, right? That's my best advice. Okay, moving on. So we have a blank flowchart proof. It's completely blank. Woo, this is a really tough one, right? It says complete the flowchart proof, and it does give us a couple things. So let's go ahead and label our picture, right? I always label the picture first. So first thing it says, hey, D is the midpoint of AC, okay? So if I have segment AC from here to here, this point in the middle, D, is the middle of that segment. Okay. What else does it give us? It gives us that AB is congruent to BC. Okay, so AB is here, congruent to BC on the other side. Awesome. What do we want to prove? We want to prove that ABD is congruent to CBD. Which angles are those? So ABD is the angle up here. CBD is also the angle up there. So I want to prove that those two purple angles are congruent, right? I'm going to take them away from the picture, but that's what I ultimately want to prove. I don't want to put them in the picture now because it would distract me later, right? They're not proven to be congruent right now, so I cannot use that. Okay, I've got 6 statements here. So let's do what we did before. We're going to write the statement up here, right? And we're going to write the reason underneath it. So always start with what you're given, right? I'm going to write that down. Always start with what you are given. And literally, what I mean by given is what is given, right? These guys, okay? So we will start by using the midpoint stuff, right? D is the midpoint of segment AC. And of course, the reason I'll put underneath it, it is given to me. Because of this statement, right, I can then say something else, right? Again, over here on our picture, D is the middle of AC, which means this part here, AD, has to be congruent to this part here, DC, right? These two smaller red segments, they have to be congruent, right? Because D is the midpoint. That's from the definition of midpoint. So then I can claim, hey, that means AD, this piece has to be congruent to CD. I can mark them. That's from the definition of midpoint. And I'll mark them twice because I already have the blue sides marked. Okay, what else do we have? Use something else we're given, right? So we've used this part, right, in the givens. We use this one. We have not used AB is congruent to BC yet. So let's use this one next. And we're going to make that claim. AB, wonderful, is congruent to BC. Why can I say that? It is also one of my 2 pieces of given information. Okay, what else is going on here? What 2 things do these triangles have? If I can prove these triangles are congruent, then I can prove these purple angles are the same, right? So again, look for the common side. They both have this line in the middle. 1, 2, 3, I'll mark it, right? And in delta math, it marks it like an X. So either way, that means BD is congruent to itself, BD. That is by the reflexive property. And I'm going to say reflexive prop, put a period there to show it's abbreviated. So now I have the triangle on the left, the smaller one on the left, this one here, right, is congruent to the triangle on the right because they both have the same 3 sides, SSS. They both have a blue side, right, here and here, right? They both have a green side here and here, and they both have a red side. So SSS is going to prove these triangles are congruent, and that will help me with my ultimate goal here. So let's label our triangles. Triangle, let's do ABD, congruent to. Now be careful, right? A corresponds to C, so I'm going to have to say C on this side. B corresponds to B, and then D corresponds to D. And that is by the side, side, side postulate or theorem. Now I have enough to finally prove this purple angle is congruent to this purple angle, right? That's angle ABD congruent to angle CBD. Have enough. Because if you know the two triangles are congruent, if you know this piece, then it's guaranteed that the corresponding parts are also congruent, right? So we call that CPCTC. And what does that stand for? Literally, question 13 asks for that. CPCTC stands for the corresponding parts. It's on one of your foldables if you well, it might be. So corresponding parts of congruent triangles are congruent. So CPCTC. It's abbreviated for that. This huge long statement, right? We say it's CPCTC. Okay, 14. So we have another 2-column proof here. Oh, we just need to fill in a couple blanks, so it's not too bad. Let's read it. It says, supply the missing statements and or reasons for the following 2-column proof. Okay. Let's go here. So what are we given here? We're given 3 things. 1, 2, 3. Oh, we're given 4 things. So we're given that WZ is perpendicular to WX, XY is perpendicular to ZY, and lastly, ZY is congruent to WZ. So I'm going to mark this one here, right? ZY is here, and then WZ is there. So both triangles have this this marked side. They're congruent. And ultimately, we want to prove, what are we trying to prove? That WZX, the angle WZX, is congruent to the angle YZX. So WZX, that's this angle here. YZX, that's this angle here. I want to prove that these two purple angles are congruent. And you can do it if you prove both triangles are congruent, right? If the top triangle, XWZ, is congruent to the bottom triangle, XYZ, if those two triangles are congruent, then of course the corresponding purple, the purple angle I've marked here must also be congruent. So that's the goal. Let's get the triangles to be congruent, and then the angles will follow. So let's do the first one here. It's got the perpendicular WZ perpendicular to WX, and then it has XY perpendicular to ZY, and then lastly ZY congruent to WZ. Notice all of these are given. Next, we don't have the statement, so it's blank here, right? But it says it's from the definition of perpendicular. Remember, if we have perpendicular line segments, that means there's right angles, okay? So it told us that, hey, WZ is going to be perpendicular to WX, which means between these two has to be a right angle at W. So there's got to be a right angle there because of the definition of perpendicular. So I'm going to mark that there. So, okay, angle W is going to be a right angle, but also it tells us that XY is perpendicular to ZY, so XY is here, ZY is there. There must be a right angle here. So I'm going to have 2 right angles, one at W at the top and one at y at the bottom. So angle W and angle Y are right angles. I'm going to use the angle symbol. And then the next statement, it says, hey, W and Y are congruent. That's because all right angles are congruent. That looks good to me. Next, we want to use a given thing. Okay, what else are we given? Honestly, this statement here, let me just double check it on my paper. Yeah, so we already have this part here. Zy is congruent to WZ, but what I think they meant to say was they wanted you to actually write it here and not up at the top. Yeah, so don't worry about this one very much. This piece was the other piece of given information. It was this piece in green. All right. Okay, lastly, we want to look for a statement about the reflexive property. So look for a common side, right? And if you look at your picture from Z to X, this side, both triangles have. So XZ is going to be congruent to XZ because of the reflexive property. Now I have enough to prove the triangles are congruent, right? So I can say triangle XYZ is congruent to triangle XWZ. Both of those must be the same. And if you look at your picture, they're both right triangles. So the top triangle has the right angle and it has the hypotenuse and leg. The bottom triangle also has the hypotenuse and leg. That is from the hypotenuse and leg postulate or theorem. And because of that, I can finally prove that this purple angle here is congruent to this purple angle there. So both of these angles are going to be congruent because the triangles are congruent. So corresponding parts of congruent triangles are also congruent, and that's that long acronym, right? CPCTC. Wonderful. All right, so we are through the proofs. Ooh, there was a lot of stuff here, right? And I know that most of these are the ones that some of y'all struggled on. It's okay, all right? It is okay. And making mistakes, making mistakes is the proof that you are trying. And that's what your teachers care about the most. Are you trying? Are you putting your effort in? And if you are, you're going to make mistakes. You have to fall off the bike before you learn how to balance, right? And you got to make mistakes in math before you really get it, okay? So we're done with this section. Let's move on. Let's move on to the solving for x. So this is the triangles, triangle angle sum and the exterior angle theorem. Okay, so the two pieces of information you want to remember for this section is that the three angles of a triangle, 1, 2, and 3, they are all going to add up to 180, right? And the second piece of information is that if you have an outside angle, angle 4, that's going to add up to angle 1 plus angle 2, right? Angle 4 equals angle 1 plus angle 2. So those are the two pieces of information you want to remember. The triangle angle sum, they all equal 180 degrees, and the exterior angle theorem. Those two are going to help us so much for the following problems on this page. So let's zoom into the first one. We want to solve for x and y, and I know I'm zooming in really, really far. It's okay. So let me actually move that back to the top here. It doesn't want to move. Oh, well. So first of all, I can consider this triangle here, and I can get x. The three angles have to add up to 180, right? So if I subtract from 180, 180 minus the 78, then minus the 54, these two. When I get rid of those two from 180, what I'm left with is going to be equal to x. So pull out your calculators, 180 minus 78, then do minus 54, and what you are left with is 48. So that is my value of x. All right, next we want to get y. My hint is to use the exterior angle theorem, okay? And here's why I say that, right? So I have this triangle over here I'm going to label in red. And I have, if I extend this side, right, the outside angle is 54. There's my exterior angle. This angle equals the other two non-adjacent angles added together. So what I'm saying is hey, that 54 has to equal 41 plus y. Again, that is from the exterior angle theorem. That's what it tells us. So solving for y is pretty straightforward. I'm going to minus 41 on both sides just so I can get rid of this 41. And when I simplify that, 54 minus 41 will bring it down to 13. And that is my value of y. 48 and 13. Okay, moving on to 2. Okay, so I have a triangle with x and y inside of it. Which one can I get first? Honestly, you can get both of these in kind of one step. I would use exterior angle theorem to get x, right? So here's my triangle, obviously, and then my outside angle is 103. And that's going to equal the sum of the two non-adjacent, the two non-adjacent interior angles. So x and 67 have to add up to give you that 103. So I'm going to write that out. Okay, x plus 67 equals 103. And then this is simple. It means one step from here, right? Get rid of the 67. So minus both sides 67. And then whatever you're left with, right? X equals the difference. So 103 minus 67. Even I'm using my calculator because I don't want to make a mistake. It's 36. Wonderful. Now it's time for y. Remember, if I know that this is 36 degrees, I can subtract from 180, right? The three inside angles. Or you can remember a linear pair, right? So this total angle of the straight line is 180 degrees. That's 103 plus y. So that means that y has to be the difference. So 180 minus 103, what I'm left with has to be equal to y. It's got to be. Because again, they add up to be the angle of a straight line because they are a linear pair. They're supplementary. And what you will get left, what you'll have left is, I believe, 77 degrees. So that's my value of y. Tricky, 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 tricky. All right, number 3. And I'm going to erase this stuff on the side because I might use this space here. So hopefully, if you wanted to copy it down. Of course, you can pause the video and copy it down. I'm not going to stop you. All right, number 3. There's a lot of moving parts to this, and we actually did a similar one in class during the scavenger hunt when you went around the room and you found all the different triangles. So we want to find x, y, and z. I'm going to write that to the side. X, I want x, I want y, I want z. Okay. Honestly, you can start with almost any of these, right? But I think let's just start with x. And my idea is, hey, this is a right angle here. And notice that right angle goes from here to here. So that gets the x and the 43. They both have to add up to that right angle, right? This angle is the right angle in the corner. And that right angle is 90 degrees. So what I'm saying is, hey, this 90 has to also equal the other two angles that are next to it. So that's x plus the 43. Okay, now finding x is a little bit simpler. Minus 43 on both sides. And whatever you are left with is your remainder for x. And you will find that x is 47 degrees. So 47. Okay. So with that in mind, let's try to find, having a hard time thinking of a way to get y, because if I look inside of this triangle, I know the 43, but I don't know z. If I knew z, I could get y. So let's get z, all right? You know, sometimes in life, you need to take a step back and look at the big picture. And that's what I'm going to do for this triangle. I'm going to redraw this triangle, the big triangle, right? And in this corner, it's the right angle. And the top corner, it's 75 degrees. And the bottom right corner, it's z degrees. Hey, I know this is 90 degrees, so I can solve for z, right? The three angles have to add up to 180, right? So 90 plus 75 plus z, that's got to give me 180 degrees. So then I will simply subtract the 75 from both sides. Excuse me, not 5. I want to subtract 75. And then subtract the 90 from both sides. So subtract 90 as well. And when you simplify and you're done with all of that, you will get z equals 15, right? That's 180 minus the 90, then minus another 75, so 15. Now we have enough. Now we know a little bit more about this triangle here. Let me change the colors. This one here. Excuse me. Here, 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 here. Because the angle over here is 43, and we know z is 15, which means y has to be the difference to get it to 180, right? So y plus the 15 plus the 43 gives me the 180. That's all the angles in the triangle. Just like before, I'm going to subtract the two things I don't need. Subtract the 43, subtract the 15. And whatever we are left with is the difference. So 180, pull up my calculator, minus 43, minus 15, and what I'm left with is 122. Those are your answers. Tricky, tricky, but yes, you know, look at the two angles, you know, that make the 90-degree angle. That's how we found x. Look at the big picture, right? We look at the big picture to get z, and then look at all the triangles you're given to try to solve for whatever you're missing, right? Okay, moving on. Number 4. Ooh, number 4 is a tricky one. So again, we just want to solve for x here and then find the value of y. So first things first, this side is marked congruent to this side, which means that this triangle must be an isosceles triangle, right? Which means that the angles that are opposite the congruent side, so this angle and this angle, must also be congruent, right? That's the isosceles triangle theorem. So if my two red angles are congruent, that means the expressions 3x plus 14 and 5x minus 8, it means those are also congruent. So you can begin by writing this, 3x plus 14. That's got to be congruent to equal to 5x minus 8. And now we can solve for x and then use that to get our value of y. This is a little bit trickier, right? I got x's on both sides. You can do a couple steps to solve this, or you could use the Desmos calculator, which I'm going to kind of show you how to do this again, right? So I'm going to put this line into Desmos, right? And then I'm going to put this line into Desmos, and I'm going to see where those two lines touch. And at the point where they touch, I'm going to take the x value. That's going to be the solution, right? So going to Desmos, let's type in our two lines. So 3x plus 14 was the first one. Here's my line. Oh, now there's my line. And then our other line was 5x minus 8. Minus 8. And if I kind of go up, you know, up enough, they will touch. Now notice I can't see where they touch, so just tap on one of the lines and then this point will pop up. You see that right there? Tap on that point and the first number is 11. That will be our value of x. So yes, we are cheating a little bit. I know, but like you have Desmos on the test, so it's not cheating, right? Use the tools that you're given, practice using those tools, and you'll get really, really good. So 11 is my value for x. I'll put that back over here. So ... use Desmos. And we got x equals 11. So that's one answer. We need to get y, okay? Need y. So don't stop. Don't just put in 11 and move on. If there's more than one thing you need to do the more than one thing, all right? Don't sleep on that. Okay, moving on. What do we got? How do I get y here? Well, again, if I knew the two angles in the bottom corners, right? If I knew those two, I could find out what's left for y because they have to add up to 180 degrees. They have to. Right, these three will all add up to 180 when I add them. So let's figure out what those bottom angles are, okay? So the angle on the bottom left, this is 3x minus 14. Well, we know what x is. It's 11. So that becomes 3 times 11 plus 14. So let's write that down. So this angle here in the bottom corner will be 3 times 11 plus 14. Put that in your calculator. So it's going to be 33 plus 14. And we will get 47 degrees. So this angle in the bottom corner is 47 degrees. It's also going to be the angle in this corner, 47 degrees, because the angles are congruent. We already know that. Which means how much is left for y, which is in the top angle, right? If this one's 47 and this one's 47, we know they all add up to 180. So that means that if I take 180 minus 47, minus more 47. What I'm left with must equal y. So I'm going to do that, 180 minus, and I'm left with 86. That is my value. Nice. Okay, moving on to 5. Ooh, gotta zoom in really far on this one, right? But just pay attention to the type of triangle again. We have another isosceles triangle. This side is marked congruent to this side. What that means is the angle across, so this angle over here, is going to be the same as this angle over here. And I know it's hard to see because my iPad's blurry, but this is x degrees right there, just like in your paper. So I know that this angle here is the same as that angle there, which means, hey, this is also x degrees, right? Because they have to be congruent. All right, well, this angle here is 100 degrees. And I know the three angles must add up to 180. So I know that x plus x, those are my two red angles, plus 100. That's got to give me 180. Now just solve for x. So minus 100 minus 100, simplify. This is x plus x, so I can write 2x equals 80. Well, 2x's is 80. I want 1x. I'm going to divide by 2 to get 1x. Both sides divide by 2. And what you're left with, half of 80 is 40. 40 degrees. Make sure that 4 looks like a 4. It's almost like a 9. You fix that. Sorry, y'all. 40. All right, number 6. These just keep getting better and better, right? All right, we want to find x. And believe it or not, we actually have enough information. If we can figure out some of the angles inside of this triangle, we can get it, right? That is the goal, right? We can put it all together. So let's figure this out. Yeah, so first of all, this 76 and this angle here are vertical angles, right? The two lines here and here intersect. So they must make vertical angles, which means this on the inside is also 76 degrees. Nice, okay. What else do I have here? Well, I know the angle of a straight line is 180 degrees. So if the angle over here is 46, that means the angle on the other side must also, it must add up with 146 to give you 180. So that means that green angle will be 36 degrees. How do I know that? Because 36 plus 146, or excuse me, it's not going to be 36. 34 degrees, my bad. 34. It's because if you take 180 and subtract 146, what I meant to say, you're left with 34. Okay. And I want to get x. Okay, and x is on the outside. Again, think of this middle triangle here, right? X is outside the triangle. It is an exterior angle. I'll mark it with make it marked with black, right? It is the exterior angle, which means it is the sum of the other two non-adjacent angles, 76 and 34. It has to be the sum of those two guys, right? So that means x equals 76 plus 34. And of course, when you get those two added together, you'll get 110 degrees. Voila. Exterior angle theorem for the win. Okay, we got a couple more over here. Let's look at number 7. Man, so much practice. Y'all are going to be perfect on the test if you practice this much. So we want to find K, we want to find H, and we want to find W. I got 3 of these. If I try to find W, it would be nice to have H, and I don't know H, so I can't really start with W, so maybe I'll start with K. Let's do this one first. Okay, or maybe H, actually. I don't know. I looked at it twice. So notice this triangle here. What type of triangle is this? This side's congruent to that side. Isosceles. There you go. Which means that the opposite angles must be congruent. So this angle in this corner here has to be congruent to this angle over here. Well, this one is H, which means this one is also H. So the bottom angles are H. Which then, what would the top angle be? Well, it'd be the sum of this 16 plus this 16. So that top angle has got to be 32 degrees, right? 16 plus 16. That's this angle. So when I look at my big triangle again, right, I've got the 32 here, and I've got H. That's not 32, that's 36. Here we go. I've got H here, and I've got H there. I can solve for H using the triangle angle sum, right? So H plus 32 has to equal 180. So subtract that 32, and I'll get 2H, right? That's H plus H, 2H, equals, okay, that's going to be 148. I just want 1H, so divide by 2. And you will be left with 1H equals half of 148, which I think is 74, but just let me double check this. Divide by 2, H equals 74. Voila. So now we can use this to get our value of W and our value of K. Which one do you want to do first, right? So let's go ahead and get W, because I know the angle of a straight line is 180. And I know that H is 74 degrees. So how much is left for W to get to that 180, right? So 74 plus W equals 180. Subtract 74 from both sides. Ooh, excuse me. 74. And what I'm left with is W will be 106. 106. Nice. Okay, I still don't have K. Great, I got W, I got H. How in the world do I get K? Well, you know, I say sometimes you got to look at the bigger picture, but you don't, you know, of course, you don't want to ignore all the small things too, right? So if I zoom in on this triangle here, right, I know the angle on the bottom. I know what H is. Yo, we know that. That's 74, and we know 16. So we can use that to find the value for K, and this is a little hint on what K is going to be here, right? So let's use that triangle to get our value. And if you need to draw that triangle on the side, you can, right? Here's K, 16's up here, and then 74 is down here. So using the triangle angle sum, K plus 16 plus 74 will equal 180. So K is going to be 90 after we subtract the other two. It's a right angle. Voila. And we have all three. Ooh, this one was a lot of work. Let's go over to 8. Ooh, yes. So I have two inside angles. I got the 2x, and I've got the 110. And I have the outside angle, and we know it is the sum of the two inside angles, which is why I said it's blue and green, blue and red. All right, so exterior angle theorem. Exterior angle theorem. So that means that 7x, that's the exterior angle, has to equal the two interior angles added up. So 2x plus 110. Now we'll just use our solving technique. So minus 2x on both sides, minus 2x. Simplify. So I get 5x equals 110. And then divide by 5. And 110 divided by 5 will be, is it 22? I think it's about 22. So that's my value of x. 22. Okay. Number 9, complete the conclusion about the diagram at the right. Okay. So I have some things that are marked and labeled, so you want to pay attention to that, right? But let's look at this first one, okay? Angle AJS is congruent to something. So AJS, that is this angle here. What other angle would it be congruent to in the picture? Well, again, this big triangle is an isosceles triangle. Isosceles, which means that the angles opposite of the sides marked congruent are congruent, right? So the two sides that I have marked congruent here are, I'm going to mark them in red, right? This side and this side, right? So the angle across from here and the angle across from there must be congruent. So that this angle over here at G must be congruent to this angle over here at J, right? So AJS, well, that's got to be congruent to the angle AGS, which would be the angle over here, right? This angle congruent to that angle. Again, because the triangle is isosceles. All right, last thing. JS congruent to what over here? Well, JS is down here, And if these two triangles are congruent, this would correspond to this side over here, GS. Again, it's corresponding sides, really is what's going on. So I'm going to erase some of this stuff just so I can kind of show that a little bit better. Because these two triangles are congruent, JS, which is this side down here, would correspond to GS on the other side. Of course, what else would it be? Okay. Nice. Ooh, special segments. This could be on the test, so watch out. Okay, I know it was one of our last lessons on Friday for on level. I don't know when honors covered it, but be really careful. Okay, median. So we'll start over here. So median will start at a vertex and it will end at the midpoint of the other side. So if you are drawing this, you got to label the midpoint, label this and this congruent, and then connect your dots. That is the median. Again, starts at a vertex up here, and it ends at the midpoint of the other side. Be careful. Angle bisector. So you have your angle, and it is a segment that cuts that angle in half, starting at the vertex. So I got to cut that in half just like that. Cut. There is my angle bisector. Altitude. So again, it's going to start at the top of the triangle, and it is going to go to the other side. It's not going to go to the midpoint. It has to be at a right angle with the base, right? It's got to be, because it measures the height of a triangle. And whenever we measure height, it's always perpendicularly. And then lastly, perpendicular bisector. So we want to find the midpoint of this side, just like we did for a median, right? Midpoint. But it's not the altitude. It's going to go straight up at a right angle with that side, right? There is my perpendicular bisector. It's perpendicular to the base, and it is a bisector to the base because it touches the midpoint. All right, so be careful. All right, and those are our 4 special segments. And we got a couple more crazy ones here on the back, right? So find the value of the variables. So first one, number 14. This side is marked congruent to that side, so I know this is an isosceles triangle. It's not going to go away. Isosceles can pop up anywhere, which means that this angle is congruent to that angle, right? And so this is also x over here. And I know the 3 angles must add up to 180, so x plus, okay, what's this angle here? 90 equals 180. So 2x equals 180 minus 90 when I subtract 90 from both sides. So that means 1x equals 90. Oh, sorry. 1x equals 45. And if you're confused about how did you do that so fast, right? I can slow it down, right? I can go back to this step. If I minus 90 on both sides, right? And I simplify. On the left side, I get 2x because, again, I have x plus x. And on the right side, I have 90. So 2 times something gives me 90. And so I'll divide both sides by 2. So divide this by 2, divide that by 2. And 90 divided by 2 is 45. So x is 45 degrees. Next one. This side is congruent to this side. This is congruent to that side. This is an equilateral triangle. Right? The other one was isosceles triangle. And in an equilateral triangle, each angle is the same. And we learned that that means x has to be 60 degrees. Each angle of an equilateral triangle is 60 degrees. That's a fact. If there's one of those you want to memorize, yeah, that would be one to memorize. For sure. And the isosceles one. Don't forget that one. And everything else. All right, moving on. Number 16, right? Again, we have isosceles triangle again, right? And how do I know that? It's because this side is congruent to that side, which means that the angles across, right? So this 58 has to be congruent to this angle over there. So this has also got to be 58. They're both 58 degrees. And that'll help me out. That'll help me out a lot when I'm finding x. So that means the top angle of this isosceles triangle, again, the big angle, right, has to be the remainder. And half of that angle is x, because this angle and this angle are marked congruent. So I want to find this top angle. I know all the angles add up to 180, so 58 plus 58 plus the question mark angle at the top, right? This big angle at the top equals 180. So I'll subtract 58 on both sides. So 180 minus the 58s. And this question mark will be 64. So that's the top angle, 64. Is it really 64? Hold up. Did I do that right? Yes, it is. Which means half of that angle will be 32. So x is 32. Number 17. Okay. I have an equilateral triangle, or sorry, isosceles triangle, because I see these two sides congruent. So this red triangle is isosceles, which means this angle and this angle are congruent. And hey, this angle and this angle are congruent because they are vertical angles here. So this has got to be 50, which means this has got to be 50. All right? Which means all the angles add up to 180. So that's 50 plus x gives you 180 because that's all the angles inside this triangle. Now get rid of the 50. So minus 50 minus 50 minus, 50 and 50. It's 100, right? Or if you don't want to do it that way, you can just do minus 50 and minus another 50. And whatever you're left with, x has to be 80. Couple more. Looks like 4 more, 5 more, 6 more. All right. Number 18. The angle measures of a triangle can be represented. So we got angles. Angle measures of a triangle can be represented as 6x plus 24, 3x minus 8, and 4x plus 21. Find the degree measure of the angles in the triangle. Ooh, that's 3 angles we have to find the degree measures of. How do we start this? Well, the triangle angle sum tells me that the angles add up to 180. So I know that 6x plus 24, this angle plus 3x minus 8, plus 4x plus 21, all of them have to equal 180. Again, that's the triangle angle sum theorem. That's what it tells us. Well, this is a lot of work if you're trying to solve for x, right? You'd have to combine all your x values, solve it, ... Honestly, put it in Desmos, right? Use Desmos. It's going to help so much when it comes to this type of problem. It'll save you so much time. So I'm going to flip over to Desmos. Type in my line, right? So what are my angles? Okay, I have 6x plus 24. That was our first one. What was our second angle? It was 3x minus 8. And then we had 4x plus 21. So this is our line. And if you can't see it, just zoom out. There it is. And I want to find out when it equals 180. But if you type in 180, nothing happens. Remember, you have to put in front of it y and then equals. Then it'll graph that line. If you don't see it, zoom out until you find it. It's up here at 180. Then tap that line and then tap that point where the green and purple line meet. We're finding it is 11. That is our value. So in the end, x equals 11. Are we done yet? It says find the degree measure of each of the angles in the triangle. We just found x. The degree measures are this, this, and that. 6x plus 24, 3x minus 8, and 4x plus 21. We're not done, but we know what x is, and that is going to help us. So use x, or to, I'm going to say plug in x, actually. Plug in x to each angle and simplify. That is the missing part. So our first angle, right? Our first one, that is 6x plus 24. Well, hey, x is 11, so that's 6 times 11 plus 24. And when you're done with that, you put that in your calculator. You should get 90 degrees. Right, second one, 3x minus 8. Okay, again, change the x out, so that's 3 times 11, then minus 8. You should be left with 25. Third one, 4x plus 21. Again, change the x out. That's 4 times 11 plus 21. And that looks like it is 65. And you can double check. If you add these three up, does it give you 180? 90 plus 25 plus 65? Yes, it gives you 180. So we got the right answers. So I will box these and move on. 90 degrees, 25 degrees, and 65 degrees are my angle measures. Number 19. I'm going to get rid of this, you're in the way. Okay, so we want to find x, y, and z. First thing is first, look at this triangle. It is equilateral, which means each angle is 60. So off the bat, x is one of the angles. Boom, checkmate, x equals 60. Got that one done. 60 degrees. We just got to find y and z. So, each angle is going to be 60, right? 60, 60, 60. That means this angle is 60. I want to get to y. I can't really get to y and z right now. I'm kind of too far away. But let's try to get these angles over here. That might help us get y and z, right? So this whole angle of the straight line, here's my line, right? That's got to be 180 degrees. Right? 60 is over here on the left, and I have these two smaller congruent blue angles on the right. These are both the same. They're marked congruent. That means I can find them, right? So basically 60 plus those question marks, right? Question mark plus question mark, right? Equals 180, right? Because they make up the straight line. So I can subtract 60 from both sides, minus 60, minus 60. You know, simplify that, and I get 120, and I've got something plus it again equals 120, and that's going to be 60. 60 plus 60 gives you 120. How would I know that? Divide 120 by 2, and you get 60. So my two smaller angles here, there and there, are both 60 degrees. 60 degrees and another 60 degrees. So if I look at... Because again, it's kind of, you know, how do I get y or z here? That helps because this entire angle will be 120 degrees, right? That's going to be extremely useful here in finding z, right? So 120, if I look at this big triangle, it is an isosceles triangle. Isosceles. I know, like, geometry is hard. Like, I get it, right? Which means that this angle here and this angle here are congruent. Well, hey, this is z, which means over here, this must be z. So in the green triangle, I've got z plus the green angle, which is 120 degrees. And that has to equal 180, right? So I can write that on the side, 2z plus 120 equals 180. Then I can subtract the 120 minus 120 minus 120. And whatever I'm left with, I'll get 2z equals, okay, 60. Right, 180 minus 120 is 60, which means 1z, when I divide by 2, 1z will be 30. I'm just double checking my work earlier. Yes, 30 degrees. So I got x. X is 60. I got z. It is 30. We have enough now to tackle y. We do. Consider the smallest triangle. I know, we're like, wow, okay, I'm considering all the triangles, right? Y is the outside angle. It's the exterior angle right here. That means it's the sum of this angle and this angle on the inside. Well, we know z is 60, and we know the other little blue angle down here, we already found this one was 60 degrees. So it has to be the 30, which is the z, plus the 60. So using exterior angle theorem, y equals the blue angle, right, plus z. And we know those two, right? The blue angle is 60 degrees and z is 30. So the y has to be 90 degrees. That is our y value. Wow. Tricky, messy work too. Okay, moving on to 20. Ooh, watch out. We have this side with an arrow marked with this side and an arrow. That means parallel. Be really, really careful about that. So I'll mark them again in blue just to kind of like highlight them a little bit, right? So parallel. So when you have parallel sides, right, parallel lines, do not forget about, and it's very important, alternate interior angles, AI, right? AI angles are congruent. So let's zoom in and try to solve for our variables. First things first, equilateral triangle. Each angle is 60, so boom, that's 60. Boom, that's 60. Right, they're all 60, which means x over here in the corner, 60. Done. Equilateral triangles are easier. Okay, now let's try to get some of our other angles. Maybe I can try to get W. We'll alternate interior angles using this is the traversal. Angle W is the same as this angle here. So I can plop W right there. But also, if we look at this triangle, it is isosceles, which means that opposite angles, so this angle over here and this angle over there, must be congruent. So that means this angle over here is congruent. So Z is the same as W. As soon as I get W, I can get Z. So let's try to find W. Consider the angle of a straight line right here, 180. 60 is this much. 90 is this much. What is left for W? So that means, hey, 60 plus 90 plus W equals 180. That's the full angle of that blue curve that I drew. Let's go ahead and get rid of 60 and 90. Minus 60 minus 90. Do the same thing over here. And what we will be left with for W is 30 degrees. So there's W, which guess what? Z is the same as W because of the isosceles triangle, right? This angle and this angle are both the same because this triangle is isosceles. So let's go back to that triangle. Now that we know what those angles are, right? We got 30 over here, 30 degrees. We got 30 over here. We want to find Y, which is the angle at the very top. So Y plus 30 plus 30, the three angles add up to 180. So let's get rid of that 30, minus 30 minus 30, minus 30 minus 30 on both sides. And you're left with Y equals 120. Voila, those are my four angles, four missing angles. Next one, the circle one again. And again, this is another isosceles triangle. These two sides are congruent, which means the opposite angles, this side and this side, are congruent. So X will equal Z. They are the same. So let's just get one of them, right? The three angles add up to 180. So X plus Z plus 51, right? 51 is that third angle, equals 180. Minus 51, minus 51. Simplify. And you're left with X plus Z equals, okay, 180 minus 51 is 129, right? Well, X and Z are the same, right? So let's just put them together. We'll say they're both X. Because they're the same, we can do that. It's called the substitution property. So 2X equals 129. Then divide by 2. And you'll find that 1X equals 129 divided by 2, 64.5 degrees. Z must be the same because they are equal. Voila. Number 22. This weird Starfleet lookalike. By the way, on your paper, there's supposed to be a side bottom here. An extra side. Okay, X is this angle here. It's the little blue angle. It's the angle between the big triangle, right? If I label this as the big triangle and the smaller triangle. It's the angle between those two. Okay, well, we could start with the big triangle or the small triangle, but they're both isosceles, right? This side and this side are congruent, which means that this angle and this angle are congruent. If I look at the big triangle, right, I'm trying to ignore the small triangle. So let's take that over to the side, big triangle, big. These sides are congruent. These angles must be congruent. And there is 32 right here in the middle. I know the angles add up to 180, right? So 32 plus 2 of those question marks, right? I've got 2 of those missing angles. Maybe I'll call those angles, Y, because I don't know what they are, right? What in the world are they? That equals to 180. So subtract 32 from both sides, minus 32, and we are left with, okay, 2 of those missing angles equals 148. Now we'll divide by 2, and that missing angle is going to be half of 148, which is 74. So this big angle here, I'll put it right here, the big angle is 74, which means this one over here is also 74, if we really wanted to label those. Okay, that still doesn't help us find x. X is the blue angle, but this green angle adds up with the blue angle to give you 74, right? Angles that are adjacent, when they add up, they'll give you the full angle. So if I can find this green angle, that would help. And if we consider the small triangle here, it is also isosceles. So if I can find the 2 green angles in the bottom corner, I can figure this out. So I'm going to redraw that one, small triangle. And I've got 76 at the top. These angles are congruent, or these sides are congruent, and these angles are congruent. So I just need to find out what one of those angles are. Call them, call this angle Z. So Z, 2Z, right, because the 2 bottom angles are the same. 2Z plus 76 must equal 180. Subtract the 76, and what are you left with? 2Z equals 104. Now divide by 2, and your 1Z, that missing angle, is going to be 52. So the green angle here, 52 degrees. Well, again, remember part plus part equals the whole, right? The whole is the red angle. The 2 parts is the blue angle and the green angle, right? Blue and green. So the whole part equals blue plus green. That is our little equation, right? Well, we know what the whole is. That's 74. We know the blue one is x. We'd like to find that one. And we know the green one, we just found that is 52. Now solve for x, right? So minus 52, simplify that, and we will be left with x equals, okay, 74 minus 52 will be 22. Voila. What a tricky problem. All of these are, but that's okay. All right, last one. Now for one that's actually looks hard, but it's actually going to be easy. This one is exterior angle theorem. Excuse me, exterior angle theorem. Okay, cool. So I have 2 inside angles, the 2x plus 10, and I have the 4x. And I have the outside angle of 5x plus 30. I know that the outside angle equals the 2 inside angles added up. So that's going to be 5x plus 30. That's got to be equal to the other 2 summed up. So that's 4x, that's the red one, plus the 2x plus 10. Again, you can use Desmos here. Use Desmos. Because there's a lot of x's here, right? You don't want to make a mistake, right? Put both of these lines in Desmos. Put this line in Desmos, right? Put the other line in Desmos. And where do those 2 lines touch? Voila, that is a solution. So let's do it. Desmos it. Okay, what are my 2 lines? So my first line is going to be the 2 in the middle, I guess. So 4x plus the other angle was 2x plus 10. I see that line. And then my other line was 5x plus 30. 30. Ah, they meet right here. I can see it. And they meet at 20. Done. X equals 20. This was a tricky review. A lot of questions, right? A lot of different strategies. Any advice, any general advice for this, Mr. Matt? Like, how can I practice this? This looks like a lot, right? It is a lot, right? In math class is more about building character, building perseverance, building patience, right? And building your problem-solving skills. Even if you don't end up using a lot of this math in your career, you will grow from the patience and grow from the problem-solving experiences into more of an efficient adult. And that's really the point of mathematics, right? Yes, a lot of you will use the numbers. Some of you won't. That's okay. But the perseverance and the character building is really, really, really what you're going to take into every aspect of your life, right? So yeah, other than that, bring your foldable to the test. Try as many of these as you can. If you didn't get this entire review video done, I don't blame you. It was really long. But yeah, try your best. Put your best effort in everything. And as your teacher, you know, for my students, I can say this. I don't know about the other teachers, but like, you know, I can tell who's putting in effort, right? And one of the big things I can tell is, are you writing? Are you drawing the triangle? Are you labeling, right? Are you using Desmos calculator? Are you writing down your work? Like if I see that work page is filled out, I know you were putting in effort, right? And that's just my best advice, right? So get the homework done, get this review done, and when you come on test day, give a lot of effort, right? And then after that, take a big break. Okie dokie. All right, good luck. I will see y'all on Wednesday and Thursday. Bye.